Everyone, welcome back to my channel. This is me Khushi. So today we're going to be doing the 8th part of Python tutorial. We are very close to finish it. So let's just start with this. So this is object oriented programming, which is OOP. So we have the classes as first. So we have previously looked at two paradigms of programming, that is statements, loops, functions, and pure functions and higher order functions. Another very popular paradigm is object-oriented programming. So we have actually three of these paradigms, which are imperative, functional, and object-oriented. Imperative has statements, loops, functions, etc. And then we have functional, which is pure functions and high order functions with recursion. Then we have the object-oriented programming, which are created using the classes, which are actually the focal point for OOP. Now, the focal point means the main point or the focus of OOP. The class describes what the object will be, but is separate from the object itself. In other words, a class can be described as an object's blueprint, description, or definition. So actually, you use a class to define an object. Now, example, I'm creating an object of, um, let's say I'm creating an object which is actually, let's say, an object to print something. So I can just use the class and I can just take out the blueprint of it and we can just have it printed out. So that is how it will work in this thing. Now next up we have classes which are created using the keyword class and indented blocks. Indented blocks in the sense spaces, which contains the class methods, which are its functions. So here we have a class cat. Then we have the def init, which is so as you can see, self, color, and legs is a little bit of description about the cat. Then we have self color, self legs, and stuff like that. So later on, we are just describing it. Ginger and 4 dog colored, 4 brown, 4, and things like that. So these are the description for the cat. The code defines the class named cat, which has two attributes, colors and legs. Then the class is used to create three separate objects of the class. So that is how this class works. Now the init, which we have seen earlier, it is a very important thing for a class. It is used when an object of a class is created using the class name as a function. So when you have the class name, that is, now let's just see an example, right? So yeah, here we have the class cat. When we're using def init will be the name, right? When we have it, we make it as a function name. The function name will also become a cat. This is okay. So all the methods must have the self as the first parameter, although it's explicitly passed. Python adds a self argument to the list for you. You need to include it when you call the methods. Within a method definition, self refers to the instance calling the method. So whenever you're creating an object or a class, you must add this self as the first parameter. But when you are actually defining the parameters, you do not need any self, and self is actually expected from it, it's excluded actually. So the instances of class have attributes which are pieces of data allocated associated with them. So the objects have a little bit of attributes which have data. In example, cat instances have attributes color and legs. These can be assessed by putting a dot and the attribute name after a instance. So here when we have this color and legs, so this thing becomes the object for this thing. Now in an init method, self.attribute can therefore be used to set the initial value of the instance's attribute. So self.attribute is used to get the value, to give each parameter a value. Now as we can see here, self.color, self.legs and stuff. And here as also we have self, color and legs. So when we have ginger and 4, it can be taken only for color and legs. So self will not be counted as a parameter. In the example above, the init method takes two arguments and assigns them to object attributes. The init method is called the constructor. So it's a constructor because it is taking two values as arguments and assign them to the object. Now, classes can have other methods defined to the add functionality. You can just add functionality in them. You can have methods in them actually. So remember that all methods must have the self as their first parameter. These methods are accessed using the same dot syntax. So in one class, you can have more than one function. You can have just 2, 3, or 4. So here we have the same dog one. So self is the first function. Other than self, there is no other parameter. So we just directly use that. We do not need any parameter defined. Classes can also have class attributes created by the assigning variables within the body of the class. These can be accessed either from instances of the class or the class itself. So here legs.4, legs is already given the value, so you can just already have the value in it. So this is a class attribute. This can be shared by all instances, like all objects of the class. So it's an attribute which can be shared by, if you have three objects in your class, this attribute can be shared by all three of them. It goes for all three of them. Now, trying to access an attribute of an instance that isn't defined causes an attribute error. Now, if you have something which is not defined yet, you cannot obviously execute that thing. Next, we have inheritance. So, inheritance provides a way to share functionality between classes. Now, as we've seen earlier, cat, dog, and rabbit. Now, cat, dog, and rabbit share something between all of them, like share a function, let's say a function of digesting food, a function of respiring, a function of excreting. So that is a function which is shared between all three of the animals. So imagining several classes, cat, dog, rabbit, so on, although they may differ in some ways, they are likely to be similar in the others, like having some similar color or some similar name is an example here. This similarity can be expressed by making them all inherit from a superclass animal. So here, this is actually the same thing as parent class and base class. So a parent class is the animal. Now under the animal, we have several other classes. Now as you see, cat, dog, and rabbit, three of them are animals. So they are inheriting the animality in them. The thing that they are an animal is what they are inheriting, what three of them are inheriting. To inherit a class from another class, put the super class name in the parentheses after the class name. So, so here in the class animal, we just have a little bit of things already defined, like the name and color, which is obviously for three of them. Name will be for three of them, class will be for three of them. So in the same way, we have these two things, which is the name and the color, will go for three of them. That is cat, dog, and rabbit. Rabbit is not given here. Now, class are inheriting something from the another class. Now, in the previous example, we had animals as a superclass and cat, dog as the subclasses. So the subclasses actually, let's understand them as superclass. Let's say so superclass. Let's say as a parent class, and the subclass is like a child class. So that is the thing. The superclass, that is animal. The parent is inheriting that from the animal, from the parent. I'm sorry. The child is inheriting that from the parent. If a class inherits from another with same attributes or method, it overrides them. This is a very important thing. If a class is inheriting, if a class inherits something from the same attributes or methods, it overrides them. In the example above, wolf is a superclass and dog is a subclass. Inheritance can also be indirect. One class can inherit from other, and then the class can inherit from the third class. So inheritance can be of many number of classes, like from A, B is inheriting from B, C is inheriting from C, D, and goes on to Y, Z, and so on. So inheritance can be infinite. However, circular inheritance is not possible. Because why is circular inheritance not possible? Now let's say we have 5 letters that are A, B, C, D, E. Now, as in the cycle, A inherits from B, sorry, B inherits from A, C from B, D from C, and E from D. Now I cannot do the thing that A is inheriting from E, because already these things are inheriting from each other, so that's a whole cycle and it's all messed up. So this cycle of inheritance cannot be created. The function super is useful inheritance related functions that refers to the parent class. It can be used to find the method with certain name in its object's super class. So super.spam we have here. So super.spam calls the method spam of the super class. So here in the super class we have the method called spam. So you can just actually call that in the next one, which is the subclasses. Object-oriented programming is something very, very important. So if you don't get it, you just need to watch the video again, because this is something very important in Python. Now we have magic methods and operators. Operator overloading. So magic methods are special ones which have double underscores between them. So here we have init actually is an example. At the beginning and end of their name. They are also known as dundles. So far, the only one we have encountered is init, but there are several others. They are used to create functionality that cannot be represented as a normal method. One of the common use of them is operator overloading. This means that defining an operator for the custom classes that allows operators such as addition or multiplication to be used on them. An example is double underscore add double underscore for addition. So here we have this. The add method allows for the definition of the custom behavior for the plus operator in our class. As you can see, it adds the corresponding attributes of the objects and returns a new object containing the result. So we have the same for subtraction, multiplication, true division, floor division, module, power, and for and. Then we have for the power, then we have for or. The expression x plus y will be translated to x dot double underscore add double underscore y. However, if x hasn't been implemented, add and x plus y are different types. So if x is implemented, you can just add it in this way. But if it is not, then you can have it in this way. And this is called the R method. Sorry. There are equivalent R methods for all magic methods just mentioned here. We have the true division again. So magic methods are also for comparison. This is lower than, this is lesser than or equal, equal, not equal, greater than or equal to. So you can use it for comparisons. If NE is not implemented, that is not equal is not implemented, it returns the opposite, which is equal. There are no relationship between the other operators. Now, as such, there's a relationship between the not equal and equal. There's nothing like that in the other ones. As you can see, you define a kind of custom behavior for the overloaded operators. Then we have for containers as well, which is len. Then we have get item, set item, delete item, iter, and contains. So we have the in one, which is the same thing. There are many other magic methods that we don't cover here, such as the call for calling objects. Then we have string, integer, and other such things. We have overridden the len function for the class vague list to return a random number. The indexing function also returns a random item in a range from the list based on the expression. Next, we have the object life cycle. So the life cycle of an object is made up of its creation, manipulation, and destruction. Obviously, the first stage of the life cycle is its creation or definition of the class which it belongs to. The next stage is instantiation for the instance when it is called. The memory is allocated to store in the instance. Just before it occurs, the new method of class is called. This is usually overridden only in the special class. After this has happened, the object is ready to be used. Other code that can interact with the object by calling functions and accessing its attributes. Eventually, it will be finished being used and can be destroyed later on. So when an object is destroyed, the memory allocated is freed up and can be used for other purposes as well. Now, as we know, when we create an object, memory in it cannot be used for the other purposes. But when you destroy it, you can use the memory for other purposes as well. Destruction of an object is when occurs when its reference count reaches zero. Reference count is the number of variables and other elements that refer to an object. If nothing is referring to it, nothing can interact with it, so it will be safely deleted. In some situations, two objects can be referred to by each other only, and therefore can be deleted as well. The delete statement reduces the reference count of an object by 1, and this often leads to the deletion of the magic method for the del statement, that is underscore double underscore del double underscore. This process of deleting objects which are no longer needed is called as garbage collection. In summary, an object's reference count increases when it's assigned with a new name or placed in container. The object's reference count decreases when it's deleted with del. Its reference is reassigned or its reference goes out of scope when an object's reference count reaches 0. Python automatically deletes it. Lower level languages like C don't have this kind of automatic memory management. So object lifecycle is actually really important because you can just manage these objects, you can delete it, you can create it, and you can destroy it as well. So this is when you have objects which you no longer need, so you can just destroy them so that you can use the memory of it. The next concept we have is data hiding. So for now, data hiding, the key part of object-oriented programming is encapsulation, which involves packaging of related variables and functions into a single easy-to-use object. A related concept is data hiding, which states that implementation details of a class should be hidden, and a clean standard interface be presented for those who want to use the class. In other programming languages, this is usually done by private methods and attributes, which block external access to a certain method and attributes and class. The Python philosophy is slightly different. It is often stated as we all are consenting adults here, meaning that you shouldn't put any arbitrary restriction on accessing parts of a class. Hence, there are no ways of enforcing a method or attribute to be strictly private. However, there are ways to discourage people from accessing the parts of a class, such as denoting that its implementation detail and should be used at their own risk. Weakly private methods and attributes have single underscore at the beginning. This signals that they are private and shouldn't be used by external code. However, it's mostly only a convention and does not stop the external code from accessing them. Its only actual effect is that from the module name import won't import variables that start with a single underscore. Now, strongly private methods and attributes have a double underscore at the beginning of their names. For example, init and all the other magic methods. They cause their names to be mangled, which means that they cannot be accessed from outside the class. The purpose of it isn't to ensure that they are kept private, but to avoid bugs if the subclasses that have methods or attributes with the same names. Name mangled methods can be still accessed externally, but by a different name. The private method of a class PAM should be accessed externally with this name. Why we use the double underscores is because you don't want, now for example, if I have two subclasses, which is, okay, one subclass which is animal, which has name as a method, and the subclass dog, which has name as a method. So if you do not have the double underscore, it can cause an error because you're using the same thing twice. So that is the main purpose of the data hiding. So yeah guys, that is it for today's video. If you like the video, just like, share, subscribe, comment down below and press the notification bell. Thank you. Bye.